Okay, good day, friends. Right now, let's continue to solve problems on conservation of momentum, conservation of energy, of course. And the problem statement goes like this. Two small steel balls are suspended on weightless and extensible threads, as shown in figure above. The masses of the balls are m1 and m2, which means they have different masses, and the lengths of the threads are l1 and l2 respectively, which means their lengths are also different. The first ball is pulled aside at an angle alpha and released. At what angle beta will the second ball swing after the collision? The collision is central and perfectly elastic. Air resistance is neglected. Okay, to understand this problem, let's look at this figure. Yeah. Okay, what is going on? We have this kind of system, two different masses, two different lengths. Yeah, lengths are seen to be different. Masses maybe not seen to be different, but the same size, the same shape does not mean they have the same mass. It's the density issue. Yeah, it has density 1, it has density 2, and that's why even though they have the same volume, the same shape, the same size, the masses don't have to be the same. Yeah, those two might be some different materials. Okay. Okay, what is it said? The first ball is pulled aside at an angle alpha and released, which means that, yeah, let me take it and put it, I don't know, maybe somewhere here, and draw it like this. Yeah, which means that this is the rope which was pulled aside. Yeah, and it is pulled at some angle alpha. Of course, when we release it, it will move some circular trajectory. You definitely know about this. It is pretty intuitive, like a simple pendulum. And when it hits this mass 2, of course, it will go up. And let's draw its situation after. Yeah, maybe like this. I don't know. Yeah. Yeah. Okay, and then definitely you know that it will also move circular direction, and this angle is beta. Okay, so as you can see, the situation is like this. Yeah. Okay, good. And to make it better, maybe better, let me draw it somewhere here so you don't get distracted. You might think that they would go up the same height. Yeah. But let's draw it different so you definitely know that those two don't have to get to the same height. Yes. Yeah, something like this, and this is some small beta. You definitely can see that those angles, alpha and beta, are not the same, and the lengths are not the same, the masses are not the same. Okay, good. Something like this happens. Yeah. In this case, it will look like mass 2 is heavier and mass 1 is lighter because when it hits the second mass, definitely does not go up very high. But it does not matter, to be honest. It does not matter which case do we consider, if mass 1 is larger or mass 2 is larger. In fact, we need formula, not numbers. Yeah. Okay, what are we going to do? What is the situation? At the very beginning, we don't have any momentum. Instead, we have energy, which is our potential energy, m1 gh1. Yeah, let's call it gh1. Okay, when it comes here, of course, it would have some velocity. When it goes to hit m2, at the very end, it would have velocity, which is, let's call it some v0. Yeah, why not? Why not? And then, of course, at the very bottom, all of its potential energy will convert into kinetic energy. Yeah, this is m1 v0 squared divided by 2. When it hits the mass 2, of course, it will keep some of its velocity. Of course, it will be lower, it would be slower, but it's still, after collision, would have some v1. It's still for mass 1, but mass 2 has some different velocity. It will also move maybe some velocity 2. Yeah? Okay. Yeah, because the collision happens. At the very beginning, we have potential energy. It is released. At the very bottom, it becomes V0. All of the potential energy converts into kinetic energy. And then when it hits with some velocity, the second ball, of course, the mass 1 keeps its velocity, but not totally, just some fraction of it. And then some of its momentum transfers into second ball. Yeah, of course. Okay, how do I approach it? First one, we can write the conservation of energy. Yeah. Let's write it here, conservation of energy, sum of energies in the beginning, sum of energies at the end. Okay, at the very first situation, let's look at this part. We're not interested in that second part, we are interested only in this part. The first energy is potential energy and the last energy is kinetic energy. It's only for mass 1, right? So it's mass 1 gh1 equals mass 1 v0 squared divided by 2. And then, right now, we can do what? We can cancel those masses out. We would have the meaning of v0 squared, and it would be 2gh1. Okay, good. But what's the meaning of that h1? It's not this height. We're not interested in this height, to be honest. This is not h1. This is not. What we are interested in is this distance. Yeah, this small distance. Why? Because only this distance, the change in this distance, creates this potential energy. It does not matter how much we lifted above. Instead, what we are left below. This is important because this difference in height, in fact, it has to be delta H1. But for not complication, let's write it like this, yeah? Okay, I would continue it like this. Maybe like this. From the central point, yeah? So we need this small, this would be the meaning of our H1, or it could be delta H1, but let's not complicate it. It's just H1. What is the meaning of its H1? If this entire part, if this entire thing, yeah, this entire red line is L1, we need to know the meaning of this one, and then subtract it, and we exactly know what is it. If this thing is circular, right? It plays the role as a radius. If this is L, then this is L as well, in fact, right? That's why this thing will be L1. But if we pulled it at some angle alpha, then this part, yeah, let me choose this part, would be what? This thing is L1 cosine alpha, right? And this entire part is L1. This small part is L1 cosine alpha. That's why the meaning of H1 will be what? H1, yeah, let me write it with red one, H1 equals to L1 minus L1 cosine alpha, and L1 can come out, which will be L1 1 minus cosine alpha. And then we can put it inside, it will be V0 squared, this will be 2G L1, and here we have 1 minus cosine alpha. Yep, good. Let's highlight it. Let's keep the meaning of it. Okay, the very same principle goes here, the very same. It goes up at the very beginning. It has just potential energy or the kinetic energy for the first situation. Yeah, for the second ball, yeah, its entire energy is m2v2 squared divided by 2, and at this height it is m2gh2. The very same thing goes, and at the end we would have something like this. Our v2 squared would be just 2gl2, 1 minus cosine beta. Yeah, the very same principle. I think that we don't have to explain it why it was so. Again, let me show it. We need this difference in height. Yeah, this would be the meaning of our H2. And if this is L, this L2, this is L2 as well. Yeah, this is L2, this is L2, right? And if we need this change in height, which creates that kinetic energy, is that we need to subtract from this entire part, L2, this part, which is L2 cosine beta. Yeah, and then we would have the very same thing like this. Okay, yeah, good. Let me highlight it as well. If you understood the first part, then you definitely understand why it was so. Okay, yeah, good. And right now, let's work with conservation of momentum. Conservation of momentum in our case goes like this. At the beginning, it was mv0, right? M1 v0, it was only its momentum, and then it created collision, and then it was something like m1 went with velocity 1, and plus, let's say, m2 went with velocity 2. Okay, good. What else? Can we write down here conservation of energy? Well, of course we can. If we consider only this part, yeah, only this case, yeah, it had kinetic energy at the very beginning. This kinetic energy created two other kinetic energies, is that with V1 and with V2. V1 is for mass 1, V2 is for mass 2. Okay, we can do conservation of energy. Just for that case, it would be m1 V0 squared divided by 2, and here m1 V1 squared divided by 2, m2 v2 squared divided by 2. And again, as you can see, cancel, cancel, cancel. And we can do what? Let's give the meaning for v1, and we can substitute it to find v2. And yeah, I'm trying, well, you will see what I'm going to do. The meaning, let's move it like this, m1 v1 and m1 v0 minus m2 v2. And the meaning for v1, let's move it a little bit lower so you can differentiate. Yeah. Okay, this would be what? This thing is m1 v0, yes, minus m2 v2 divided by m1. Okay, this thing would be important. Let's remember this thing. And the very same thing we can do with this one. It would be what? It would be m1 v1 squared. Here we have m1 v0 squared minus m2 v2 squared. And then to find the meaning of v1 squared, it would be just m1 v0 squared minus m2 v2 squared divided by m1. Okay, and if you ask me why did I choose v1 as the meaning, well, we can right now equalify this thing to this thing, and then what we will have just the meanings of v0 and v2, v0 and v2, and that's exactly what we have here, right? Good. Okay, let's make those two things equal to each other. To make it equal, as you can see, it is squared form, and let's make some square here. Then at the middle, yeah, let's write it with red. It would look something like this. m1 v0 minus m2 v2. It must be squared. this is m1 squared as well. And all these, why? Because this is simple form and this is squared form, and we need to make this whole part square to make it equal to this one, right? This would be m1 v0 squared minus m2 v2 squared and divided by m1. As you can see, m1 cancels out with this square, and there, what are we going to have? We can open this whole thing, but instead, let me take it and work with it somewhere here, maybe. Let's continue with black one. Yeah, here we're going to have m1 squared v0 squared minus 2 m1 m2 v0 v2 plus m2 squared v2 squared. Okay, at that side, if I move that m1, this m1 to that side, it would be what? It would be m1 squared v0 squared minus m1 m2 v2 squared. Okay, okay. And what do we have? We can cancel this m squared v0 squared because we have those in both sides. Yeah. I can do what? I can move this thing, as you can see, move this thing to this side and move this thing to this side. And then we can have something like this. This thing would become positive. It would be m1 m2 v2 squared plus m2 squared v2 squared. That side it would be m1 m2 v0 v2. And as you can see, the v2 comes out, v2 squared even. This would be m1 m2 plus m2 squared. This thing is m1 m2 v0 v2. Yeah, cancels out. This cancels out. Yeah, and the meaning of v2 is here. As you can see, this is 2m m1 m2 v0 right now. This is, well, one of the mass 2 can come out. This thing is m1 plus m2, right? And I can just cancel. The meaning of v2 is found. This would be the meaning of v2, I'm sorry. This is m1 plus m2. Okay, good. And what can we do next? Well, what can we do next is just do conservation of energy, yeah, which is this one. We didn't use it. Still, we have found the meaning of v2, and right now we can make it equal to this one, yeah. v2 squared. This is v2. So in order to make it equal to 2g L2 1 minus cosine beta, this thing has to be squared, yeah. Let's write it maybe here. This is 2m v0. This is m1, I guess. m1 plus m2. This whole thing has to be squared. Yes, m1 v0, yeah, yes. And 2gl2. 2gl2. This is 1 minus cosine beta. Yeah, right, beta. Yes, beta. Good. And right now we can also, yeah. What we're going to have is something like this. This will be 4. This will be m1 squared. This will be v0 squared. Below we would have something like m1 plus m2 squared equals 2gl2 1 minus cosine beta. Okay, we know the meaning of v0 squared, which is exactly here. We can put it there, and then we would have 4m1 squared 2gl1 1 minus cosine alpha. This is m1 plus m2. This would be 2gl2 1 minus cosine beta. And what can we do? We can cancel 2g. And to find the meaning of cosine beta, well, definitely it's something like this. L2 goes, well, yeah, let's see. L2 goes below, yeah, it would be 4m1 squared. Let me write it like this. 4m1 squared divided by that thing, m1 plus m2. This is squared. This is squared. And also here we have L1 divided by L2. And here, what else? This is 1 minus cosine alpha. Yes, this thing becomes 1 minus cosine beta. And we can change this here and this whole thing here, and then we would have the meaning of our cosine beta. That would be our answer. Cosine beta would be minus 1 minus, oops, this whole thing. Yep. Let me move it somewhere here maybe. Let's move this step here so you can definitely see it. Okay, this is the answer that we have here. Okay, this is good. This is the answer. Let me highlight it. Okay. However, However, there is one problem to it. The original answer looks different. The original answer looks like this. Yeah, let me write it here. Answer. And if I look at it, it would look something like this. Beta equals 2 arc sine. And here what we have, it's sine, alpha divided by 2. And also 2m1. Here we have m1 plus m2. And square root L1 divided by L2. Okay, this has to be our answer. Okay, let me highlight it with red. Yeah, which indicates that we didn't give this answer. But in fact, maybe we did. Maybe we did. I have some idea. Let's stop in here. Yeah, this one. Let's take this one, this green one, and concentrate on it. In fact, this is correct answer. It's the very same answer, but let me prove it to you. Well, let's see why does it have alpha divided by 2 in its answer. We can do it something like this. We can approach cosine. We can approach cosine as like this. Cosine alpha can also be, well, we have beta in our case, that's why. Cosine beta can also be considered as cosine 2 multiplied beta divided by 2. Well, nothing changes yet. 2 and 2, those two cancel out, and then we will have beta divided, just beta, yeah? But it is also what? This is also cosine 2 theta, yeah? Where this beta divided by 2 plays the role of this theta, yeah? Okay, good. And we have several formulas for cosine theta too. Yeah, it would look like this. Cosine 2 theta is what? It is cosine squared theta minus sine squared theta. Also cosine 2 theta has other formulas like 2 cosine squared theta minus 1, or cosine 2 theta equals 1 minus 2 sine squared theta, something like this. I'm interested in the last one, in this one. If you ask me why, in the answer we have sine, which means that, well, we need to convert that cosine into sine, yeah? And we need to remember that our theta is not just beta, is beta divided by 2. This is important, yeah? And then we can do something like this. If I take this answer here, right? I put it here. Let's take it out. And then I can convert this cosine beta into what? It was cosine 2 beta divided by 2, and then it can convert it into what? If I had, it had to be 1 minus 2 sine squared beta divided by 2, right? And if I put it here, it must be 1 plus, yeah, because when I open the brackets, minus becomes plus. This would be 2 sine squared beta divided by 2, and then these two cancel out with each other. And the very same principle goes for this alpha, in fact. The very same principle. Let me open this maybe like probably here. And I would write here the very same principle for alpha. This thing would be plus already. This would be 2 sine squared alpha divided by 2. Yeah, and these 1 minus 1 just cancels out. Okay, good. And right now we already have what we need. Let me take it somewhere here. Oops, no. Yep, okay. And this is exactly what we need. As you can see right now, we have here, well, we can cancel those, I believe. Can we? Yeah, we have what? Let me just write it here. The very total thing that we have here is this one. Let me delete this one. Even it is here equals. This thing can be deleted. This thing as well. Let's put it here. And right now, as you can see, I can cancel this one. And also, I can put square root to both sides because this is sine squared. This is also, and if I put square root to both sides, yeah, let's move it a little bit somewhere here so it was some space here, and then we would have that answer. As you can see, this would be 4 becomes 2, m1 squared becomes just m1. This thing becomes m1 plus m2. Just yeah, L2 divided by L, or L1 divided by L2 goes in square root itself, and sine squared will be just sine alpha divided by 2. This thing would be also sine beta divided by 2. Okay, yeah, that is exactly what we need. And right now we can do arc sine, and it would be beta divided by 2. This thing would be arc sine, and inside of the brackets, everything what we have in here. Yeah, I can put this sine maybe a little bit closer like this, maybe it's multiplication sign. And you see that this is beta divided by 2, and if we move it here, it would be just 2 arcsine. And this would be our answer, beta equals 2 arcsine. So which means that we had our answer correctly, but it was just in different form. But it is correct. Yeah, this is what we were meant to find. Beta equals 2 arcsine, it is here. Sine alpha divided by 2 is there. 2m1 and divided by m1 plus m2 is also there. And square root L1 divided by L2 is also there. So in fact, we solved this problem correctly in here, but just in different form. And I hope that it was pretty clear to you. If you didn't understand, you can write me privately. But if you did, I would be very happy. Yeah, thanks for your attention. Goodbye.